In today's video, you're going to learn everything you need to know about type annotations in TypeScript. And we're also going to cover the basic types in TypeScript and how to give different values type annotations. And then I'm also going to touch on one thing here at the end that is going to be really important for you to know when writing your TypeScript code. So first off, a type annotation is where you explicitly give some value a type within TypeScript. So it's where you would explicitly say that, okay, this variable is going to hold a value that contains this type. All right. So let me show you how you do this for some various types. So here on line 9, I declare a constant called number. And then as you can see here, after my number label, I use a colon. And this is going to be used to give something a type annotation. And then following that colon, I'm going to use the keyword number. So what I'm saying here is that this constant called the number is going to contain a value that is of type number. And to explicitly say that, I use this annotation right here. I use colon number. And as you can see, then I have my assignment operator and I assign the value of 10 to my num. And then when I hover over my number here, VS Code is going to tell me the type annotation here. It's going to say num is colon number. So this is a number type. And if I try to assign any other data type to this num here, I'm going to get an error. So if I try to do some string here, you see I get the red squiggly under my num because it says type string is not assignable to type number. So here I'm explicitly saying that this variable needs to contain a value that is of type number. And if I don't use a number here for my assignment operator, I'm going to get an error. And even if I try to reassign this num to a string here, I'm still going to get an error because this is going to have to be a number for any value that it holds. But since I used a let declaration here, and if I try to reassign it to another number, that's going to be totally fine. All right, so that is how you do a number type annotation. Now you can do a very similar thing for a big int. Right here, I have a constant called big int, and then I use my colon big int keyword for my type annotation. I'm saying this variable is going to contain a value that holds a big int, and then I assign that to a big int here. And if I tried to assign this to anything other than a big int, I would get an error. And then the same thing can be done for strings. I say const channel colon string. So channel is going to hold the value that is a string, and I assign that to code Ryan. And if I tried to assign that to any other data type, I'm going to get an error. And then you can do the same thing for booleans here. So I have a constant called show modal, and I use colon boolean saying this variable is going to contain a value that is a true false value, a boolean, and then I assign that to false. But if I try to assign that to the string false, I get an error because that is no longer type boolean here. Now arrays are a little bit more tricky for type annotations, as there's kind of a couple different ways that you can do it. You can use a generic syntax, which I will touch on generics in future videos, or you can just use a bit different syntax that I personally find a little bit more readable, but it can be up to you on what you like better. So one way to do this is here on line 22, I have const array1, and I use colon, and then right here I say number, and then a opening and closing pair of square brackets, which this is also how you create an array literal using the opening and closing square brackets. So what this is saying is that array1 here, it's going to hold a array that contains numbers. So this is a number array data type that this array is going to hold. And as you can see, I assign it to an array that contains numbers. But if I try to add any non-numbers to this array, you see that I get an error. I'm trying to assign a string to type number because this needs to be a number array. Now with this, I could also do a string array here. And then if I got rid of all of my numbers, that is totally fine. Or I could also do a Boolean array, and I could change this to the value of true, and that's totally fine as well. But what if you want an array to contain multiple data types? Well, the way that you could do this is I could wrap a pair of parentheses around this Boolean here, and then I could use the OR operator. So this is going to be a Boolean or number array. So now if I add a number to this array like that, you see that I don't get any errors because this array contains booleans or numbers. But if I try to add a string here to this array, you see that I get an error. Type string is not assignable to type number or boolean. And you could use this or operator for other variables as well. If you know that some variable within your program is going to be either type A or type B, you could use the or operator. But if the types get much more complex than just a couple of types, then it's probably best to use something called type aliasing, which I'll cover in future videos. So this is one way to use a type annotation for your arrays, but you can also use the generic syntax, which is what I do in line 24. So whenever you see these opening and closing kind of pointer brackets, I'm not really sure what these are called, that is kind of the generic syntax. So what I'm saying here is array2 is going to be of data type. Well, it's going to be an array. So you can use the capital A array keyword here. And then you can open a pair of left and right brackets. I think that makes a little bit more sense. And then I can put what data type is going to be within this array. So this is going to be an array that contains strings, which is what I assign it to here. But if it was an array that contains numbers here, I get an error. But you could also use the or operator and say, hey, this is actually going to be an array that contains numbers or strings. And then you can see that that compiles because these strings here are either numbers or strings. All right, so those are two ways to use type annotations for arrays. Personally, I kind of like this syntax better, but I can also see how people might prefer this right here. All right. Now, TypeScript also allows you to use type annotations for null and undefined here, as you can see. So I'm saying const n colon null, and I assign it to null. But if I try to assign that to a string, I get an error because a string is not assignable to type null. And then the same thing for undefined. U colon undefined equals undefined. But if I try to assign that to a string here, I get an error because I can't assign a string undefined to the value of undefined. And then the last type annotation we'll cover in this video is for the function return value as well as function parameters. So you can give function parameters type annotations, just how I give any of my kind of declarations here, type annotations. So within my parameters, I can use colon and then whatever the data type is for that. So I'm saying this function here is going to have two parameters, A and B, and those are going to be of type number. So I'm expecting this function to be passed two numbers here. And then this could be any data type that I use above. It could be null, undefined, string, boolean, whatever you might want to pass to your function. And following the parentheses, I use colon number. And that's saying this function is going to return a number. So to specify the return value of a function, following your parentheses, you can use a colon and then give it a type annotation. Just like you gave all these variables type annotations, following the parentheses, you can give the return value of your function a type annotation. So I'm saying this function returns a number. And right now, everything works because I'm returning A plus B, and TypeScript knows that since A and B are both numbers, well, if I return A plus B, it's going to be a number. But if I change this to a string, TypeScript's going to be mad at me because it's like, hey, you're clearly returning a number here because A and B are numbers, but you're saying that this function returns a string. I think you have something wrong here. And it says number is not assignable to type string. But if I just returned a string here, it's going to compile because I do indeed return a string. All right. Now, one thing that's important to remember is that you don't always need to use type annotations because TypeScript has something called type inference. And that was my very last video on TypeScript. So I definitely recommend checking that out for a full explanation. But in certain situations, TypeScript is going to know what the data type of a value is, and you don't need to explicitly say it. So here on line 41, I declare a variable called number and I assign that to 12. And TypeScript already knows, it already infers that since I'm initializing this variable with a number here, it's going to just infer that, okay, this is going to be of type number. And if I try to reassign number here to a string, it's not going to work because TypeScript's going to infer that this is supposed to be a number. It's going to say type string is not assignable to type a number. So if you initialize a variable and assign it to a certain value, TypeScript's automatically going to infer that that variable is going to contain the data type of whatever value you assign it to. And it will do the same thing if I use like default values. So if I give a default value to the value B here as 1, it's going to infer that within this function definition, since I already initialized this parameter with a value, it's going to assume that this is going to be of type number, as you can see in the kind of type annotation code hint above. All right, so TypeScript can infer the type of a variable and can infer your types in various situations. And I would ultimately use type inference basically wherever you can. Sometimes I do like to specify the return value of a function because that can avoid some errors, which I cover in my type inference video. But for the most part, I would let TypeScript just kind of infer where you can, because it makes your code a little bit more readable and you don't have all these type annotations kind of floating around everywhere. But there are going to be specific situations in which you need to use a type annotation, and you need to say that this variable is assignable to these different types of values. So you definitely still need to know type annotations within your programs. All right. So coming soon, we'll cover type inference, type aliasing, never, void, unknown, enum. All those are coming in future videos. This was just kind of a video on the basic types in TypeScript and how to use type annotations and what those are as well. So thanks for tuning in, and I'll see you in that next one.